deviating from recent patterns, recent data that has been collected. And the big debate centers around whether human activities have been shown to be accountable for that climate change. So here we are ready to talk about an issue that's atmospheric, and that is the idea of a greenhouse gas. Now, greenhouse gas isn't anything that's mysterious. Every substance, every molecular substance, interacts with electromagnetic radiation in a certain way. The way we typically see that is color. So we have a thing called a dye or a pigment. We put it in a shirt. That dye is such that it, in the visible wavelength range, Roy G. Bibb, red, orange, yellow, green, blue, indigo, violet, when visible light hits that dye, it absorbs all the wavelengths except red. It reflects the red. That's why we see the color. Now, even outside the visible range, if you have UV, if you have infrared, and all the way to gamma rays on the short end, and all the way to radio waves on the long end, you have a specific interaction between every wavelength and every molecular substance in the universe. These are characteristic, so that a particular compound like sulfur dioxide will have a certain couple of characteristic absorption peaks. Now, that relationship between matter and energy is universal. So carbon dioxide is a relatively small component of our atmosphere, 0.03 to 0.05%, not 5%, but 0.05% of the gas in the atmosphere is carbon dioxide. But in fact, we're doing a lot to release carbon dioxide. Most of that is through combustion. Burning coal, burning natural gas, burning petroleum. All of these things generate carbon dioxide, and these fossil fuels are the very things that pulled carbon dioxide out of the atmosphere in the past. So you pull it out, you put it in the body of a plant, put it in the body of an animal, then you bury those remains, you crush them under incredible pressures, heat for long periods of time, and they turn into one of these fossil fuels. Carbon dioxide is only one of the things that's released when you burn those things. Now, methane, CH4, is also a product of burning carbon materials. Ruminants like cattle, especially feedlots, give off tremendous amounts of methane. Rice paddies, since rice is such a major crop and grows anaerobically underwater, a lot of methane comes off of there. Methane is a molecule that actually absorbs and re-radiates energy at a higher rate than carbon dioxide. So it could be a major factor in atmospheric warming. Nitrous oxide is a byproduct and a contaminant of vehicle engines, of agricultural processes, and other sources. So although we view it as a contaminant, it does have a greenhouse gas effect. The whole point here is that we're basically interfering with the radiation that's coming from the sun by absorbing it and re-radiating it as infrared, which basically contributes to the temperature. We can, in fact, project what will happen if we increase the concentration to a certain degree. Computer models are always only as good as the modeler. What assumptions were made and what ideas, what hypotheses are being tested. When they're run without input, then we basically can't match the historical climate that we have. But when humans and human contributions, the contributions of human society are included, then past historical records begin to match the models. And so we think that human inputs are necessary in order to have good prediction into the future, because that is one of the things we are very interested in. The science of demography is the study of human numbers, and that study, just the numbers of people on the planet, us the ability to look forward, because there could always be an unusual event that affects human population. Right now, all of us are in the midst of the coronavirus pandemic. But in fact, if you look at human population numbers, there won't be any impact on expansion or shrinkage of human populations by this thing that seems so dramatic, so grand to us. So here we see the observations shown in that gray and black line, models using only natural forcings, and I don't like that label because I think of humans as a natural feature, but that's all biology except humans, shows you the blue line prediction. And models using those natural features, in quotes, plus anthropogenic effect, shows you the pink region. And you'll notice that the actual observations match when human factors are added in. So separating that out, the evidence has been overwhelming. And here we are back to the American Geophysical Union. Now, this is a group of scientists, of PhDs from around the world who have studied all areas, oceanographers and terrestrial biologists contributing information about their observations, all the weather measurements, all the climate measurements. This is their summary statement. As best as can be determined, the world is now warmer than it has been at any point in the last 2 millennia, 2,000 years. And if current trends continue, by the end of the century, it will likely be hotter than at any point in the last 2 million years. Now, that's enough of a strong statement. If the American Geophysical Union has put that out as their summary of current trends, that's a fairly strong statement, and it catches your attention. If we're looking at the hottest in 2 million years, that's a time scale where kind of short-term and mid-term and natural variation, little ice ages and so forth, they don't extend for that period of time. So it leads us to think something's going on that's unusual. And given the correspondence between recent temperature change and human activities, we are looking at our own impact. So what do we see? 0.6 of a degree centigrade or a degree Fahrenheit in the last century. 16 of the warmest years in the past 150 years have occurred since 1998. Now, that's a clustering of warm years that actually looks very unusual. When we look back at evidence of temperature variation that we can draw from the permanent record, like the sea floor, the ice caps, the strata, we don't see this kind of clustering repeated. We can, by measurements, determine that the warmest, the fastest warming is occurring at the poles, where all of that water is locked up in ice. And it's occurred over the last 50 years. 7 degrees Fahrenheit on average. In Alaska and Canada, where it's cold enough typically that the ground is frozen the majority of the year, their growing season might be 4 weeks. And during that time, it might thaw down to 8 inches or 9 inches before it refreezes. That's called permafrost. If you go there at the height of the growing season in Alaska and Canada, and you dig down through that typically saturated soil, because the liquid water is sitting on top of ice, within 6-8 inches you get to ice, frozen soil. Trees are toppling over because their rooting depends on a solid ice foundation. If you melt it down to water, the soil is soggy, basically can't hold the tree up. Arctic sea ice, Antarctic sea ice, these shelves are reducing and even disappearing. Glaciers all over the world are retreating. There's a wonderful book by Ernest Hemingway called The Snows of Kilimanjaro. Kilimanjaro is a gigantic mountain that I think is like within 300 miles of the equator in Africa. But it has, in all recent memory, been witnessed as having an ice cap all year round. It's above the frost line. But in recent years, the ice cap has disappeared, and Kilimanjaro is without snow for a major part of the year. We do see a rise, measurable rise in sea level that would be accounted for by the melting of ice, and that also means that bare water, the liquid water, is absorbing more heat. So when we look at all of these things together, what does that mean? Here in the Northern Hemisphere, I garden, and I'm typically used to planting in what's called Zone 6. It's now changed to Zone 5, a warmer zone, and it's written that way on all the seed packets that I buy. We're seeing not a steady warming everywhere on a globe that's spinning with flowing water, with flowing atmosphere, with uneven cloud cover, with an uneven distribution of land and water, all those factors we talked about. You do not expect it to warm steadily in all locations. But if we are seeing an energy increase in the atmosphere, what you expect is what I'd call turbulence. Some places will be drier, severe droughts. Some places will be wetter, and floods will be more dramatic. You'll see changes in the patterns of animal movements and animal life cycle stages. So if the spring comes earlier, the birds will migrate earlier. You'll also see movement of ranges as ranges of animals and plants shift. Now this would be occurring for animals, they can shift pretty quickly, but plants, that would take more on the decades to hundreds of years to actually adjust to a warming climate. But you'll also see those animals that don't move well. An animal range movement is sort of like a new group of introduced species, which will interfere as new ranges overlap. And you'll see an increase in threat and extinction. It's going to be expensive to address this simply because the processes that are contributing to climate change are so ingrained in our basic maintenance. So the idea of fossil fuel is one we've developed over centuries because it has real value. The Industrial Revolution of burning coal to make steam and using the steam engine first as a workforce generator. The estimates now is that 5% of the world's gross domestic product would be necessary to reduce greenhouse gas emissions. However, this is one of those things where 5% being terrible news, if we wait, the cost goes up. If we're going to stabilize climate, these kinds of predictions always scare me. And I have to admit, I haven't looked into the lists of tables and data myself, but these are coming from the preeminent scientists of our day. Energy production will need to be 80% decarbonized by the year 2050, just 40 years from now, in order to stabilize our climate. Now, stabilizing our climate is kind of like stopping a supertanker that's full of oil. Once you decide to stop and reverse the engines, it's going to be, something like 12 or 13 miles before you actually bring the ship to a halt. But in fact, what we need to do is look for the trend moving in the right direction and ask that question. Are we to a point where warming is slowing and warming is coming to a halt? Even if it takes decades for it to reach that balance point, the trend here could tell us which way we are looking. Now, it turns out that right now, we continue to increase our emissions every year. Richer countries are ones that can look to technology. They can consider more expense. Poorer countries simply don't have the infrastructure. We're talking about everything from wood and dung that is used as household fires to coal and other products, kerosene, which are burned for heat, for cooking, for basic home by home uses. Combating climate change. Emissions trading is an idea that places a commercial value on CO2 production. So if you want to manufacture or if you want to burn a lot of fossil fuels in excess of a per capita limit that has been set by international agreement, you then have to buy emission credits from a country which is emitting less than its CO2 limit. So this does represent a transfer of money from typically richer to typically poorer countries. But it's evidence that poorer country will not increase its emissions, and the emission you are doing will be compensated. Technology sharing, trying to take those CO2 saving technologies and disperse them. Deforestation can have a big effect. If we continue to cut down the trees, trees are a major absorber of CO2 and can slow the rate of CO2 increase. And finally, poorer countries responding to climate change, this disparity of the so-called first, second, and third worlds and their economic abundance is a serious problem, in that even if countries that are well developed, like the Scandinavian countries, generally get very good marks in terms of their social consciousness, but they typically are small and have a limited number of people. Large poor countries are going to continue to emit. So when I say turbulent, I mean episodes like flooding, like storms, like disease. So the Greenland land mass is located in a place at a very high latitude so that it contains a lot of ice. Antarctica is a polar continent covered with ice. We can measure the thickness of the ice and figure out how much water is there. And melting those ice caps completely would change coastal areas and the sea level by 100 meters. Insurance companies are already beginning to include this in their actuarial tables, and the price of insurance for living within a certain distance of the coastline. And that figure right there is startling. 33% of the world's population lives within a reasonable distance of the coast. Now, this is in places where you would not expect. For example, Australia is this large dry continent with several coastal areas that are wet. But in Australia, about 80% of the population lives within 50 miles of the coast. There have been international meetings, the so-called Kyoto Protocol in '97. A lot of countries did set targets and meet them for emissions of greenhouse gases. We did exempt China and India because of their tremendous population and their markets. And they also want to improve the living standard and the wealth in their countries. This is a problem because they are major emitters. However, it's important to point out that smaller countries like Australia and even the United States did not ratify the agreement, so they did not join in to this voluntary process. 2015, a Paris Agreement brought together 195 countries to agree on greenhouse emissions, among other ecological factors. And the idea of what is a ceiling temperature that we can tolerate, global average temperature increase has to be stopped by 2 degrees centigrade increase. And that's above the kind of the baseline that we set before industry really began burning fossil fuels. I also agree that the target really should be 1.5 degrees centigrade, but given our current activities, we did not think that was within reach. The plans so far would not meet, based on the science, would not project to meet that 2-degree guideline. So we are meeting periodically. 2020 is the meeting to set new guidelines to basically moderate this temperature increase. Financing is going to be important. So the contribution from a country like the United States would be especially important, having the largest economy in the world. But so far, the overall impact of the money and the activities has not been met. Paris Accord required ratification by at least 55 countries, which was 55% of the global emissions. And within a year, 55 countries had stepped forward. You know that the United States is currently withdrawn from that and not participating. Now, how can we work creatively in the future? Rather than a whole approach, what can we do that's kind of piecemeal in order to affect this climate change? Carbon trading is something that I mentioned. Basically, the countries that want to emit more will pay for the privilege by buying the carbon emission limits from countries that are under their emission limit. This is really a situation that's taken off. Look at this, 140 billion tons of carbon emission worth $53 billion. That's a significant amount of money has been traded under these accords. But so far, it's not enough to address the problem. We look at it now more piecemeal. We recognize this isn't going to do the whole job, but it will allow us to attack small and doable pieces. The overall target right here, stabilize carbon emissions by cutting 7 gigatons over the next 50 years. And when we look at specific segments of this 7 gigatons, what's reachable? Well, it turns out our personal vehicles have a very big impact on these emissions. If we double our vehicle efficiency and cut our driving in half, we would save 1.5 gigatons. At our homes, looking at energy efficient appliances, lighting, and insulating the building could save another 2. And capturing and storing carbon emissions so they don't go into the atmosphere could save another. So here we are at 4.5 gigatons out of 7. We're still losing ground. This wedge analysis sort of shows our historical patterns. This is billions of tons of carbon growing from, what does that look like, 2 to 6 in the 50 years between 1950 and 2000. And the question is, where do we go from here? If we go on our current path, we're going to be up to over 10 billion tons a year by 2050. However, these wedges, 1, 2, regarding vehicle efficiency, building efficiency and insulation, power plant management, and that includes both more efficient operations, cleaner sources of energy, but it also includes a more economical look at the energy that we use. Other practices are being instituted. I'm going to hurry along. This is a figure showing carbon capture. So power stations, which typically put out a lot of CO2, in Sweden that CO2 is being captured and stored underground in a safe manner. So coal fields that are underground will absorb this. And when you pump CO2 in, the pressure of the gas forces methane out of the ground, then it can be captured and used as fuel. CO2 can be pumped into saline aquifers. CO2 is very soluble in water, and so this is basically just a storage device. Saline aquifers, because any groundwater that's fresh water is important for human use, but saline aquifers are recognized as not useful. Can't use it for drinking or irrigation. Finally, this shows CO2 being pumped into oil fields, and this is sort of an analog to what we call fracking. So pump in enough CO2, and what happens is the pressure increases, and it forces oil from places that normally would not use its yield its oil, and aids extraction while it's storing CO2. So these items do show some promise for the future. Should we focus on methane? We do know methane comes from things like landfills. That sanitary landfill will promote decay, but it also emits methane. Rice paddies, we've mentioned, oil wells and coal mines also are major emitters of methane. I've also mentioned feedlots, so that when we're feeding that beef, that is so important to us. Methane is a major product that comes out of every feedlot when we're finishing the cattle. We do see some countries taking the initiative. The UK, New Zealand, and Germany are working hard to reduce their emissions and have achieved some reasonable success in moving in that direction. New Zealand has pledged to be carbon neutral, basically balancing their carbon emissions with greenhouse gas reduction. Denmark is now going heavily into windmills and plans to increase to 50%. And they've pledged to reduce carbon emissions significantly. I want to point something out, though. That seems like such a simple statement. Denmark is about a quarter of the area of the state of Missouri. About 1/4, 25% of our area. Denmark also has about the same number of people as the state of Missouri. So with respect to geography and with respect to the number of people, it's kind of easier to reach a consensus, and it's fitting into their economy. Although I would say Denmark and the Scandinavian countries above them have been proactive in maintaining environmental quality. They typically lead in the thinking that is successful. U.S. emissions has grown by 9% since 1990, but declined a bit since 2008. And mainly that's because we're taking coal burning out of our use. So this summary statement, what can you do? This vertical axis is population emissions reduction, and it is what are those reachable technologies, things we know how to do, things that we could implement now from an engineering standpoint that would have a major effect. So the bigger the block, the more impact it would have on carbon emissions. So what are we looking at here? This looks like about 230 down to maybe 170, 175. So that's 55 units of reduction just by implementing fuel efficiencies on our personal vehicles. Number two, if we put more people in each car, carpooling and trip chaining, so we are sharing our vehicles rather than driving one vehicle per person. We get this second major block. Now, weatherization has to do with our buildings. But here, number four is driving behavior. If we drive differently, we can save gas and also cut emissions. So 1, 2, and 4 in terms of the rank deal with our personal vehicles. Down below, if you read through here, here's our home appliances, our home heating, thermostat settings, our habits, how warm do we want things. When we get down here, here's 2 more vehicle items, routine auto maintenance and low rolling resistance tires. Now they're much lower rank, but when you put these two together with 4, 2, and 1, you can see that a major reduction can come just from changing the way we deal with our personal vehicles. So I'm going to kind of conclude by saying climate change is a scientifically accepted trend right now, even though it's socially denied